Well, hello everyone. Today's notes are on trigonometry applications, places where we actually use trigonometry in the real world. So first example in front of you says find the height of this water tower. So what I did, I went for a little walk during my lunch today, and actually this was yesterday. So yesterday I went for a little walk in downtown Oregon, took this picture of the water tower in downtown Oregon. Then I stepped 95 feet away and measured to the tip of the water tower. That's 40 degrees. So I want to know how tall that water tower is. All right, so let's see what we can do to find this. So we're looking for this height. I'm just going to label it h, which seems to fit. That's your height. We've got a right triangle here. If we extend this upward, so that means we can use some trigonometry. So from that 40-degree angle, we could say opposite and adjacent are labeled. So we can say the tangent of 40 degrees equals opposite over adjacent. And if we find tangent of 40 degrees on our calculator, don't forget, make sure you're in degree mode. Multiply that by 95, we have our height. So the height of that water tower, I should say, is about equal to, about 79.7 feet. All right, good. So we have a method of measuring the height of that water tower without actually climbing up and putting our lives at risk. Let's look at another example. So okay, I went walking around on my lunch. So here's, last weekend I was kind of bored, so I was looking for another application. So drove out to New York, went to the Statue of Liberty. It was beautiful. Look at that blue sky behind it. It was beautiful. So made some measurements. So I was standing exactly a mile away, and I measured a couple different angles here. Now I want to know this height of the statue, not the base. Now notice that height doesn't make a right triangle. So what I need to do is think of this whole thing as a right triangle and somehow figure out that height of the statue. First thing I'm going to do is find this entire height right here. And I'm going to call that x. Okay? So we can say again, we can use tangent here. The tangent of, now it's this entire angle here. So that's going to be 15.9 degrees equals x over 5,280 feet. And again, if we use our calculator, let it do a little work, we get that x, the entire height, is about 1,504 feet. Now that's the entire height. I just want to know the height of the statue. We still can't do it using trigonometry, but we can find this height, the height of the base. I'm going to call that y. And I can say the tangent of 11.3 degrees is equal to y over 5,280 feet. Solving for y, letting our calculator do some work, we get y is about equal to, that's about 1,055 feet, about 1,055 feet. So if we subtract these values, we now have the height of the statue, what we're looking for. And if we do that, we get that height is 449 feet. Perfect. So even when we don't have a right triangle, as long as we can make one, we can still use trigonometry. All right, I don't know if that answer is 100% accurate. My measurement here was not entirely precise, but based on these measures, that would be the height of the Statue of Liberty. Okay, so after all this traveling, I needed to relax a little bit. So let's check out this problem here. Okay, so this problem reads, this text looks a little funny, but we'll read it here. One night when I was playing records on my record player. Has anyone ever seen a record player before? Oh, wonderful invention. You should all get one. Anyways, I'm playing some records and a fly was sitting on my favorite Barry Manilow album, just spinning around. So, of course, I've got to use mathematics here. So I timed number of seconds and the distance that fly is away from me in centimeters. Okay, it says find a sine regression model for this situation and interpret the model. So first thing we want to do is enter this data into a couple lists on our calculator. So I'm going to put this screen aside. There's my calculator. And I'm going to press my stat key and enter the data into a couple lists. Now I've already got this data in here. Time is in list 1 and distance is in list 2. Now we know it's going to be a sine regression model, and if you think about it, this fly is going to be farther than closer, farther than closer. It's going to follow a sine curve. So I'm going to press my stat key, go over to calc, and I want to calculate a sine regression model. Sine regression is one of the last options in this menu. And there it is. So I want a sine regression model of the data in list 1 and list 2. Okay, so it's calculating, and there is the data that I need. Okay. So let me write down that equation. So we get y equals, well, it says a times the sine of bx plus c plus d. And it gives me what all those values are. So it's going to be y equals about 2.4 times the sine of, let's see here, about 0.59 x minus 0.85 plus 7.3. Okay, so basically what this is saying is if we were to graph this, and I don't need my calculator anymore, let's put that aside. If we were to graph this thing, it would look something like this. So I'm going to just kind of make a sketch of a sine curve. So the thing about this fly riding around on this record here, he's farther from us and he gets closer to us, and he's farther from us and he gets closer to us. And actually, here's where we are. We're at 0 down here. This distance here is determined by d, so that's 7.3 centimeters. So that means we are sitting 7 centimeters, 7.3 centimeters away from the center of that record as it's spinning around. A is this distance here, 2.4 centimeters. So that fly is 2.4 centimeters from the center of that record. So he's farther away, closer, farther away, closer. These values determine how long it takes the fly to go all the way around. Okay, so when we interpret the model, each of these values means something. It's not just some number you plug into an equation. They all mean something about where that fly is sitting on this record. Okay, let's go on to our next problem. So this is an actual problem that Mr. Prawl encountered. So what he wanted to do is cut a 12-inch high arc above a doorway. Let me draw this for you. So we've got this doorway here, and these rectangular doorways are kind of boring. So he wanted to make this doorway so it was curved, just kind of cut that right out. And I'm going to grab my eraser and just get rid of that rectangular door. So it's this arched entryway. So you might have an arched entry between your living room and dining room, let's say. Well, how on earth are we going to figure out how to cut that arch? What we really need to know is if we were to measure this and kind of draw a line on that ceiling to be cut, what we really need to know is this radius. So I'm just going to make a little bit bigger diagram here, something that we can work with a little easier. So I've got this big doorway here. I've got this arch coming upward. Now, we're looking for R. We're looking for this radius. It's going to go down to here. And for this radius right here, which is the same as this radius on this side. Now, if I draw straight up from there, we'll make that perpendicular. I know the height of the arch is 12 inches, right? Now, we don't know the width, but if I think of this right triangle, I have half the width right here in this spot. I'll make that green. There's half the width. This length right here is going to be, well, if I went all the way to the top, that'd be R. So that's going to be R minus 12. So now, no trigonometry needed, but we can use the Pythagorean theorem with this right triangle here. We could say R minus 12, quantity squared, plus W over 2, quantity squared, equals R squared. Now, if you write this out twice and square that, you'll get R squared minus 24R plus 144. Squaring what's in this next set of parentheses, we can say plus W squared over 4 equals R squared. Now, one very convenient thing here is that we have an R squared on both sides of the equation. So now we can solve for R in terms of W. Let's get that R by itself. So we can say negative 24R equals w squared over 4 minus 144. And if we divide by negative 24, we get r equals, well, dividing by negative 24 is like multiplying by 1 over negative 24. So we get negative w squared over 96 plus, so we divided by negative, plus 6. And actually that negative is kind of making me a little nervous here. So the reason, I think I made a mistake back here. When I move this over, this should have been negative. So when we divide by that other negative, this should be positive. So the radius that we should cut this at is the width of the door squared, divided by 96, plus 6. This is the exact equation that Mr. Prawl uses to cut these circular arches over doorways. So if the doorway is, let's say, 10 feet wide, you take 10 squared divided by 96, add 6 to that, and that's going to be the radius of the arch that you should cut. Wow, an actual use for the Pythagorean theorem. I don't believe it. Okay, one last problem. This might be the most challenging problem that you'll ever see in this class all year. We need to solve for D. We've got two right triangles here. We know this entire distance along the bottom is 30 kilometers. We know these angle measures. And D is this height right here. Now, in order to solve for D, we're going to have to think of these right triangles. And I'm just going to put an X down here to show that this distance to this point in the middle here, we don't know. Let's call it X. But since the whole thing is 30, I can call this one on this side 30 minus X. So now we can use some tangent ratios. I can say the tangent of 14 degrees equals D over X. And in fact, we can solve that for D and say D equals X times the tangent of 14 degrees, whatever that happens to be. Okay, now I can do the same thing on this side. I can say the tangent of 34 degrees equals D over 30 minus X. And solving for D gives me D equals 30 minus X times the tangent of 34 degrees. Now check this out. If D equals all this stuff and D equals all this stuff, those items must be equal to each other. So now we can say X times the tangent of 14 degrees must be equal to 30 minus X times the tangent of 34 degrees. Let's distribute this to clean this up. So now we can say that must be equal to 30 times the tangent of 34 degrees minus X times the tangent of 34 degrees. And now if we get our X's on the same side, we can say X times the tangent of 14 degrees plus X times the tangent of 34 degrees equals 30 times the tangent of 34 degrees. All right, what I want to do is pull an X out of both these terms. Let's write this over here. So that gives me X times the tangent of 14 degrees plus the tangent of 34 degrees equals 30 times the tangent of 34 degrees. And we almost have X by itself. If we divide by this stuff here, I'm going to put it up here. X equals 30 times the tangent of 34 degrees divided by the tangent of 14 degrees plus the tangent of 34 degrees. Don't try to simplify. This is something we can plug in our calculator and find what X is. Now once we do that, we'll find that X is about 21.9 kilometers. Now we have to be careful because we just found X, which is right here. We're looking for D. So at this point we need to use our tangent ratio. We say the tangent of 14 equals D over 21.9. If we do that, we'll get D is about equal to, well, it's going to be around 5.5 kilometers. Now, if you can do that problem, you can do anything I could possibly throw at you. If you can't do that, don't worry too much about it. Okay, your homework assignment. 6 problems. You're doing some modeling in here, so see what you can do on these 6, and let me know what questions you have as you're working through these.